Crab or carbapenem resistant Acinetobacter. By definition, these are resistant to meropenem. So how does sulbactam acts on these bacteria, which are difficult to treat? So as you can see in this figure, when we give a standard dose of sulbactam, it passes through the porine channel and reaches the cytoplasmic membrane, where it has to face the beta-lactamase enzymes, which could be class A, class B, class C, or class D. The most important enzyme is the OXA enzyme, specifically OXA23, which is produced by Acinetobacter. These enzymes kill sulbactam, and the standard dose is not able to kill Acinetobacter. Sulbactam is a substrate to all of these enzymes, all classes. Then how does it act on carbapenem-resistant Acinetobacter? The answer is high dose sulbactam. If we give very high dose of sulbactam, like in this figure, it saturates all these enzymes, including the most important OXA enzyme, and still some sulbactam is left to act on the target site, that is penicillin binding protein 1A and 1B in the cytoplasmic membrane, plus penicillin binding protein 3. By binding to these enzymes, it acts as a beta-lactam and kills the bacteria. The IDSA guideline, which was released in 2024, states and recommends a combination of sulbactam and durlobactam as a first-line treatment for carbapenem-resistant Acinetobacter. What does durlobactam do? Sulbactam inhibits the OXA2358, that is class D enzymes, which are most frequently seen in Acinetobacter, and thus it spares the sulbactam. The sulbactam is free to act on its sites, which are penicillin binding protein 1A, 1B, and 3, and hence even low dose sulbactam can act on crab. However, the problem is sulbactam durlobactam is available only in US and China, and not available in the rest of the world. So what is the next best option available for the rest of the world? It is high dose MP sulbactam, in which almost 9 grams to 12 grams of sulbactam is used per day. Plus, this should be given as a part of combination therapy with some other class of drugs which have shown sensitivity in vitro. Examples are polymyxin B, tetracyclines like minocycline or tigecycline, or cefiderocol. Newer drugs available, not yet available in many countries, are ervacycline and cefepime zidebactam, which might be useful in crab. However, the clinical data for these is sparse. Thank you.